Hey everyone, today we will be talking about this problem statement. It is called next permutation. Let's read out the problem statement. A permutation of an array of integers is an arrangement of its members into a sequence or linear order. For example, an array is 1 to 3 and the following are all the permutations 1 to 3, 1 3 2, 2 1 3 and so on. Now the problem statement says that next permutation of an array of integers is the next lexicographically greater permutation of its integer. Basically, if I write these numbers as 1 2 3, so the next greater number is 132, and this is the next lexicographically permutation. Okay, now it says while the next permutation of the array 3 to 1 is 1 to 3, because 3 to 1 does not have a lexicographically larger rearrangement. So basically if I rearrange this as 3 to 1, so then from these numbers there is not a possibility that we can generate a bigger number from this. So lexicographically next permutation will be 1 2 3, like it will again start from 1 to 3 only. This is what they mean. Now we have to write a function that will take this array, this a number. For example, it can take this 132 and it has to return the next lexicographically greater number. So in this, for example, in this case 132, the next number will be 2 1 3. If I am not wrong, let me just cross verify. 132 213, yeah, here it is. So this is what we have to write. Now after going through the problem statement, what we can think is that given an array of number, there can be different permutations. For example, for this number set, there can be permutations starting from 1 to 3, 132, 213, 231, 312 and 321. So one possible approach is that we generate all this permutation number for the given number and figure out the next greater number and return that. But this will be very inefficient approach, as generating all this number will take the n factorial time complexity. So it's not a very efficient approach. Now let's try to think of how can we improve it. So if we take a much more better example, like if we take 1 2 5 4 3, so here what we need to do, like if we just check, can we replace 3 with some number which can make it a bigger number overall. So is there any element? Yeah, there are 5 and 4, but if we replace 3 with 5 and 4, then 3 will take this more significant position and overall the number will be lesser. So we have to find a number by which we replace it with the next greater number will make it get the next permutation in order. So for that, if I just look at this combination, so here this is an increasing, right, and from here it started decreasing, like the numbers are greater and here it is lower. So if I just replace this 2 with its next greater number from this subarray, which is 3, then I can get the next bigger number. So it will become 1 3 5 4 2. Yeah, so this number is definitely greater than this number, but it's not the next in order. I can see that can be a number in between these two combination. So for that, if I reverse this order, so basically this number should have the lowest number combination. So if 1 3 2 4 5, if I just reverse it, then I can get the next permutation order. Okay, so we just need to find this number, this index, at which we have to perform these two operations. First is swap this number with the next greater number, and then reverse this subarray. Now let's write the code for this approach. So we'll take int I equals to nums.length minus 2 while I is greater than equals to 0, and nums of I plus 1 is less than equals to nums of I minus minus. So basically this loop is traversing until there's increasing elements. And now if I is greater than equals to 0, which means that we got a number, then int j equals to nums.length minus 1 while nums of j is less than equal to nums of I j minus minus, we swap nums of I comma j, and after this we just need to reverse the subarray. J equals to nums dot length minus 1 while I is less than j, swap nums of I comma j, I plus plus j minus minus, and we need to define a function private void swap int nums int I int j int temp equals to nums dot I equals to nums of j, and nums of j equals to temp. We have to make it static. Alright, so this is our function. We'll just provide our example to it. 1 2 5 4 3, and we'll just run it. So here we got the output as 1 3 2 4 5, which was the expected output 1 3 2 4 5. So yeah, this is the solution for this problem statement. I hope you enjoyed the video. If you do, please like the video and subscribe so that it gives me a feedback that these lectures are helpful, and I'll keep on making more such videos. Thank you.